A large language model is an AI system that is trained on large data sets to understand and generate human-like language effectively. Some of the technologies used are self-attention mechanisms that allow the model to weigh the importance of different words and different contexts, along with massive pre-training on diverse data sets, which will improve generalization, and then fine-tuning and instruction tuning, which adapts the model for very specific tasks for whatever the issue that you're utilizing it for. Importance of techniques of prompt engineering and prompt engineering in general. Prompt engineering is a practice of design that is refining inputs and can and to guide the LLMs towards producing accurate, relevant, and safe outputs. The important critical pieces are the LLM's context sensitivity, which is the way a question is phrased and can drastically affect those responses that you get. This prompt engineering helps reduce hallucinations, improve task accuracy, and ensure alignment with user intents and user inputs. In production systems, prompt engineering optimizes costs, latencies, and reliability without restraining the model itself. Embedding. The definition of embeddings. Embeddings are numerical vectors representing text or data, mapping semantic similarity to geometric proximities. The role that this will play is embedding enables semantic searches by retrieving contextually relevant information based on query similarities, which we will go over better examples of at the end, and used in retrieval augmented generation. Embedding enhances RAG formats by combining retrieval and generative models for accuracy, context awareness responses, trying to give it a better accuracy level and feeding relevant information for these use case scenarios. Applications in clustering and recommendation. Embedding groups similar items and suggest relevant content through clustering and recommendation systems. Once again, this is all to increase the accuracy and the longevity of information being outputted by these LLMs. Real world scenarios. So a common situation is a chatbot faced difficulty retrieving relevant knowledge-based articles for complex user questions. And that could be because the information is sparse. It could be because the person asking the question may not be wording the question in a good way for that LLM to understand it. If you can't ask the right question, it can't give you the right information. Or if it doesn't know what kind of question you're asking, it can't give you that correct information. So the objective is to improve retrieval accuracy without retaining the large language model to enhance chatbot effectiveness. Implementation is apply a RAG pipeline using embeddings stored in a vector database to augment response generation. So instead of having to retrain that entire model and put in, multiple man hours and other expenses such as having to retrain it and however long this may be down, everything else that goes into this is just attaching another piece to it that it can pull from to further increase the accuracy of the answers that it's given out. And in some cases, the answer relevance can be increased by 40%, follow-up queries decreased, and user satisfaction improved significantly. Every time you do one of these, this is the answer you want to see. You want to see a relevance increased by a significant number that has been approved of, less follow-up queries because that will just eat up more server power and it costs more money. So it's one of those balancing acts of, if I put this in here to help with this level of question that we're seeing a lot of, then overall you'll decrease dollars per day or so much over the years to equate to that cost.